Hello, can we start now?
Yes, sir, we can start.
103. 103 now. Let me see some people in YouTube. Um,
So please let's wait for a while.
hey, why are we not finishing our data? And those people are sleeping.
So some of us we
It's
don't
not
have
fair.
we are running out of data. So please let's start.
We don't have what?
We are running
Yes.
out of data, and the time was stated on the
And
page. Let's start.
Thank you. So thank you. I agree with you. We can't wait for people who are sleeping.
Let's start. We don't have what? We are running out of data, and the time was stated on the page. Let's start.
It's not entering.
Then apply saliva.
Sorry, what is not entering?
It's not entering.
Then apply saliva oil.
The saliva too are finished.
Please make rectify.
Hello? Sorry, the net has
Hello,
started.
sir.
Yeah, so let's start. Last week we tried looking at the physiology of the nervous system. So we looked at the how the impulse is generated, how impulses are generated in the neuron. So we are looking at. I just want to take on that. Yes, yes.
Please record for us.
Hey, you people recording. Record in your brain. You see that some people will not join. They want to listen to that one. No problem. Okay. So we try looking at how impulses are generated, how they are even initiated in the neuron, and then move from one point to the other. Already in anatomy, we said physiology, no, the nervous system is made out of these cables. Okay. Um, who is saying that if we can have sign language? Hey, who are you talking about sign language? Okay. I don't understand. Maybe the person is somewhere. We tried looking at in the anatomy, like I was saying, the brain is made out of neurons, and then, or the nervous system in general, made out of the neuron and neuroclia. And then after that, we said the neurons are the basic units, and they help in the transmission of these impulses, either from periphery to the central nervous system, or from the central nervous system to the peripheral part. And they are like wires, they are like cables. So the impulses are supposed to travel in a continuous manner. If there is any cut anywhere, these impulses cannot travel. And we, in the physiology, we're now trying to look at how the impulse is like. And we're saying that the impulse is just the movement or charges, the exchange of charges across the plasma membrane of the neuron. Where if a neuron is resting, it has the inner part or the intracellular part is negatively charged, and then the extracellular part is positively charged. And when the neuron is stimulated, then there are ion channels, like the sodium ion channels, that are open, and they allow sodium to run into the cell. And with some time, potassium ion are also ion channels are open to allow potassium ion to efflux, to come out of the cell. And that moving in and out of ions is what we are talking about as the impulse. So that will happen from where the neurons start to be stimulated to the end of it, and maybe continue to do other activities. So we try looking at that. Then now, so this we said this process or impulse is called the action potential, which is characterized by depolarization, rapid depolarization, and slow repolarization. So we looked at what are the factors that cause the depolarization, and we said it's due to the opening of sodium ion channels. Opening of sodium ion channels. when sodium ions are open, channels are open, sodium, there's influx of sodium. And when sodium is entering, they drive the membrane potential towards their equilibrium potential, okay, which is plus 60. But it will not get to the plus 60, but around plus 30 millivolts. Why? Because sodium ion channel quickly enter into an inactivation phase. And also at the same time, there will be opening of potassium ion channel to allow potassium efflux. Then, when sodium is entering, the third factor why it will not reach the plus 30 is that the third factor is that when sodium is entering into the intracellular part, the intracellular part become more positive and therefore repel better positive ions from coming in. Very good. Then at that level, because potassium ion channels are open, potassium efflux occurs. And if potassium is coming out, they are also driving the membrane potential towards their equilibrium potential. Therefore, there is repolarization. So the curve starts, if you look at 4, it starts to come down. Okay, start to come down there. Okay. Then because potassium will open for a longer period of time, it will reach minus 90 millivolts. And after that, it is the resting membrane is restored. What are the factors that enable or that contribute to the resting membrane potential? This we mention 3 factors that contribute to resting membrane potential. So one of them is that during the resting phase, the plasma membrane of the neuron is 50 to 75 times permeable to potassium than it is to sodium ion. Therefore, there is that high possibility of potassium moving in and out of the cell membrane than sodium moving in and out. And when potassium is moving in and out of the cell, it drives the membrane potential toward minus 90. But it will not reach 90 at the resting because there will also be movement of sodium ion, and therefore there will be that kind of a bit neutralization. Okay, so that is what happens. Then the other factor is that the activities of the sodium potassium ATP, which is a carrier molecules on the plasma membrane, usually will carry 3 sodium out and 2 potassium into the cell. And this indirectly will create a concentration gradient across the plasma membrane. And that allow the moving in and out of these charges across the plasma membrane along their concentration gradient. Okay. So somebody is saying what? Okay, you say what? Who is applying saliva? Oh, so you to listen. You are applying saliva. Fine. Somebody said the frontal lobe might be having some challenges. So yes, you just this. I will send you the result. The result is ready for the yesterday. I can hardly hear. Sorry. kindly check. But I think other people are listening, are hearing me. Maybe check your mic rather. Check your distance rather. Please, everyone hearing? Yes. Somebody say no. Yes, no, yes, no. That is how it is. Okay, yes, no, yes, no. Check your mic. If others are hearing, then it's from yours. Okay. So, if you have any question on last week, yes, last week lecture, that is this one. You can still ask. Somebody said, hey, my duty about results. So is it? Yes, I can hear. Okay. Oh, yeah, the result is ready. I wanted to send it, but I want to ask
Hello.
you. Yes. Somebody said, what?
No.
Go over the article. I'm a bit confused. Still last week, you're so confused. Yes, talk. Who is talking?
Doc, please, it may be out of the lectures, but I wanted to find out a chunk of my colleagues were not able to write the IAS due to network challenges, and I want to find out how you are going to help them.
Why network challenges?
Yes, please. And some couldn't log in at all.
Yes, sir.
Look at them. It's from the phone. Maybe it's from your phone or something. But I had about 370 responses. I don't know your total number. I was about 300.
More than 400.
Seriously?
Yes.
Hey. So
So
where
a
are they over?
lot of people couldn't do it because of network.
This one is not true. Some people they didn't want to answer.
Doc, so kindly suggest that we plead that they give them some at least 30 minutes to do it, maybe.
So I'll set
If
different questions for them. Or
that is fine, Doc.
no problem. When are people reporting to school?
Within the weekends.
This
Monday
weekend?
we start. Yes, please.
I
Yes,
thought
Doc.
it's this weekend or is this weekend?
This very weekends.
Wow.
So our first lecture start on 30th. That's Monday.
Oh, okay.
Yes.
I want to travel. Wow. I'm shocked. I thought it's next weekend you are coming. Okay, so no problem. Let's so next week. Wow. Okay. We'll sort it out.
Thank you, Doc.
But then the numbers who are joining today are not encouraging. It used to be more than this. What is happening? Let me see. Because the YouTube, there are 20, and then the Zoom, we are just 190, making about 210, which is not good. If you say you are about 400, at least last time we could be like 3 something, which is fine. So where are the rest?
Yes, sir. Please, I think sometimes the link delays, so that's how it affects us.
Oh, but they didn't delay like what? But they put it at the same time, oh? I don't understand.
We the reps don't get the link early because some of the people will be asking, is the class coming on? Where is the link? And then
So then when you get confirmed, yes, it will come off. Is that not it? As for the link,
yes,
just come.
we do confirm, but if the link gets late, then it means some will be reluctant because they may think the class will not come on.
Oh, no, that's not the reason. They think that when it's time to go to class, imagine you are going to the physical classroom. When it's time to go to class, you one,
Dog,
yeah.
dog, it's
Yeah,
like today, the whole day. I think there's classes we had from morning till now. We're having the same issue. It's like the network challenges. Sometimes the people may come on and then you see they will start dropping because of the network. It's like today itself, the network is not all that stable.
yeah, even my own. You see, I cut off like 2 times before I now I'm able to connect.
Yeah, I think that is the issue because most of them are complaining on the platform that they can't join because of the network.
Look at who is saying, Edward, you are saying we weren't aware of today's lecture. Hey, are you sure? And Jay, you hear what your people are saying. They say they are not aware. Many things on the timetable.
No, it is not true for my people there. They knew it.
Yes, we told them all right, but sometimes the link, we should get it early.
So that one. Okay, so let's go on. Let me see. We are now 196. So, and the YouTube is it's even reduced to 19. I have a complaint on network. I couldn't join. Don't understand anything. Well, don't worry, you understand. You understand. I'm just reading the messages. So now those. So we're just looking at a review on that. So let's continue. If you read here, all the things we talked about is stated there. Now, what we look at is uh, how active potential is degenerated. So we said the active potential arises as a result of a successive increase in the conductance of the membrane to sodium and potassium ions. So that is what we are talking about. So it is due to the conduction across the membrane of these ions, sodium and potassium ions. And this one, take note of that, like factors that bring about repolarization. Already, when I was starting, I mentioned them. The repolarization is due to the sodium ion getting into inactivated phase. I believe you've heard of that. Where is my pen? So here it is. So the sodium. So number one, I said sodium ion. Immediately the channel when they open, then they go into what we call inactivation phase. Then number two, Hello, yeah. Sorry, like we're saying, the internet is misbehaving here too. It's like that. Yeah. So we're talking about three things. So number one, we said the sodium ion channel getting into inactivation state. Okay. Do I anyway 36? Okay. Then they also repel. Then number three, this is what I want to talk of. The calcium, sodium ion, potassium ion opening. So these are the three factors that contribute to repolarization. Okay, so take note of that. They will come in the exam. Okay. Then when the potassium ion channel closes, we have the resting membrane now restored. And I will say, how does it get restored? Okay. So you know the sodium ion will now be inside. Remember there was rush in of sodium ion. And then there was also efflux of potassium ion. So these will be moved by the sodium potassium ATP, which is a carrier molecule on the plasma membrane. So those are the three factors. Now, the action potential, like last I drew something and I say we usually have depolarization, repolarization, and then it can restore to resting membrane, then depolarization, repolarization. So it should do this way all around like this. Okay, so this is what we refer to as the conduction. So it goes this way, okay, all the way to the terminal axons and maybe continue or do others. So if you take, so that means this is a full cycle of action potential, another cycle here, okay, and then another cycle that, okay. So it will be doing that to the whole, if this is the neuron cell body, and then this is the axon that runs. So axon and end with the terminal button, terminal axon in that. Okay. So it will do that in all. We call it the conduction. Okay. Now, propagation of the action potential are of two types because we have some neurons that are myelinated and some are non-myelinated. This one I've drawn here, number one, is a non-myelinated neuron. But if you have another neuron this way, and then this way, okay, so this is another neuron, and maybe this one is myelinated. That means it's covered by swan cell or oligodendrocyte, depending on where they are located. So this is the axon, this is covered. This one covered. Yes, Jay, your hand is up. You can talk. I'm making my drawing.
Okay.
Yes.
So I wanted to know, neurons are supposed to be myelinated. So how come we have some neurons? Neurons are supposed to be, the axons are supposed to be myelinated. So how come we have some that are not myelinated?
We have some neurons that are not myelinated, and also it depends on if your brain cell neurons are more myelinated, are well myelinated. That's why you be a shark in a way. You get that impulses will travel very fast, and if your they are not all that myelinated, then you'll be a fish.
Sir,
Yes,
please, my network fluctuated, so I didn't hear the beginning.
is it okay?
Yes, please.
So, yes, I was trying to answer your question that there are some nerves in the body that specifically, like that is their nature. Okay, they do not get myelinated. That is how they are made. We have neuron like the postganglionic neurons. Postganglionic parasympathetic neurons are not myelinated. So that is how they are made. And then I was saying that depending on your brain, maybe there may be some neurons that are not myelinated, but which were supposed to be myelinated in a way. Okay.
And is that a disease?
Yeah, so it means that maybe somebody was asking, what can you do to be a shark? And we're like, eating your diet and all that. So if the diet you are taking is deficient of nutrients, maybe it could have effects on this myelination. Yeah, so it may not. Yeah, so that's some of the things that can happen. Yeah, clue hand was up. You can talk. Let me see. James.
Thank you, sir. I was just going to add up to what's the name. What I read about the myelinated and non-myelinated, about what Jay is asking.
Okay.
I was told that the non-myelinated, they send impulses that are not so quick and fast, whilst the myelinated send quick impulses. So I read, and they said an example was within the lobe of the ear and then the dorsal side of the foot. So I wanted to ask if that is also right or not. Yes, sir. Thank you. Sir, did you get me? Network. Hello, sir. So, Sir Jay, if only you can hear me, I don't know, that was the little study I also did. They said the non-myelinated, that the impulses they carry are not so quick, whilst the myelinated, they have impulses that are very, very, very quick. And then a typical example was within the lobes of the ears, and then what's the name? The soles of the foot. Around those, there are some places there that impulses are not so quick like that. Okay.
Okay, so then if I understand what Seth said and then that of yours, then it means that naturally we have some neurons that are not myelinated. And then and naturally we have some that are myelinated. Now, if there's a case that a neuron that is supposed to be myelinated naturally is unmyelinated, then it means there is a disease.
Yes.
James, your hand is still up.
Thank you for unmuting me. Because of what you said, I was going to say yes, but I think our sister said it. So if those areas, that cell possibly is not, what's the name? If it is supposed to be myelinated, is not myelinated well, then possibly it could be a condition. Maybe cell will have to come and then we'll verify that much better.
Yeah, sure. I think he said something like that. That sometimes the nutrition too is your nutrition is also plays a role.
Sure. With the nutrition, Abi, he said that a lot. What's the name? Mr. Newman was asking what we could do to help buff the cells, and then what's the name? The brain itself to function more properly. He said certain nutrition, especially protein, helps those nerves to actually be very functional in themselves. So definitely, I think nutrition too plays a much bigger role in seeing the functionality of those nerves. Thank you.
Great. So if there's more of the explanations, please, you guys should bring it out there. We are enjoying it.
Sure. And if some of you have questions, just raise your hand. As we wait for him, raise your hands so that maybe if you ask and some of us have ideas about it, then maybe we'll...
Hello.
Okay, Kelly.
Yeah. Please, so my network wasn't good when you started. So please, can you explain to me? And the myelination you were saying, I don't know what is that. I don't understand.
Okay. So the myelination, I don't know if the last time you were in the class, but myelination basically is just like how do I even put it? It's like a covering of the neuron. You understand? Like a covering. The other time we learned that there's a particular cell that is responsible for that. That is the oligodendrocyte. They actually wind around the neurons to prevent what do you call it? They prevent the neurons or the axons from getting into contact with each other. Yeah, so the myelination is basically the covering that insulates the neuron. So, for instance, if it is unmyelinated, then it means that shed is. You see that there is some rubber around it. So, in the case of the neuron, we can liken it to that, and that if you take off the rubber, when you touch it, or you might get shocked. Yes. So the unmyelinated ones are cables without what the insulators around them or the rubbers around them. And then the myelinated are the ones that have the rubbers around them. So we were asking, are all neurons supposed to be myelinated? Are they supposed to have rubber coverings around them? And then we were made to know that some neurons occur naturally, do not have myelinations around them. And that those neurons occur naturally. And there are some that have these myelins around them that are myelinated. And they are saying that those myelinated ones will transport impulses very fast, quickly. And those without the myelin shed, or those that are not myelinated, transport impulses, at a slow pace. Yes, I don't know if you answered. Thank you.
Thank you very much, Doctor. You're welcome.
Thank you. Thank you. I like the class that when I'm off, somebody took over.
Yes.
Yes, you've done very well. So you have to clap for the person, and when you are coming, you bring the person one ball of cake. Everybody, bring that person a ball of cake, okay?
Okay.
All right, so like he was saying, we have myelinated neurons and non-myelinated neurons. And like I've drawn it here, you can see the myelinated ones, they are gaps, and these gaps are referred to as the notobranchiates. So during impulse transmission, like we're talking about the action potential, the sodium and ion moving in and out, they will only occur at these gaps. The gaps, these we call the node of Ramsey. So it will jump from this.
Hello, doctor.
Yes.
Sorry. Jay, please make him the host so that he can record for us.
Okay.
Thank you.
Yeah, then he decided to be the host. So
No, sir. It was given to me automatically because I joined immediately after the link was created.
all right, no problem. All right. So the impulses or the movement of the action potential will move from this gap to this one and jump to this one, jump to this one. And this process of impulse propagation is what we call saltatory conduction. So the process by which impulses are conducted across the myelinated neuron is by saltatory conduction. But if your brain cells are non-myelinated, that means, let's say if this side is A, so let me draw here, A here. Okay, there you have B here. So impulses will move from A to B, then to C, to D, like that, continuously. Then we refer to it as continuous conduction. It's continuous conduction. Yeah. So that is what we are saying. So we have two types of conduction of impulse, that is continuous and what? Saltatory conduction. And we're saying that saltatory occurs in myelinated neurons, where the impulses jump from one node of Ramsey to another node of Ramsey. So those gaps. By continuous conduction, it occurs in non-myelinated neurons, where the impulses are travel continuously. So get like the name goes, continuously in that. Okay. And therefore, impulses traveling in the non-myelinated neurons are slow, or impulses will get to where they are going late than if your brain cells are myelinated. So that is saltatory. And yeah, so this is an example of saltatory. Look at this here. Number one here is not myelinated. So that's where you have the sodium ion channel. So to move from here, then all this play the sodium ion channel. So it will quickly move to another gap. And then from this gap, it moves to another one. And then it moves like that. Therefore, this is called saltatory conduction. Now, there are properties of action potential. Properties of action potential. And there are just four. So one of them is a threshold. We already explained that the minimum intensity that will result in the generation of an action potential is called a threshold. We talked about that. If the stimulus is not up to a threshold, then it will result in what we refer to as local or local response or graded response. Okay, local response or graded response. If it's up to a threshold, the minimum intensity of the stimulus or supra threshold, then an action potential will result. So one property of action potential is that the stimulus must be up to what? The threshold. If it's a sub-threshold, then a graded response would result. That is what we are saying. Then 2, action potential is usually all or none. It has a property called all or none property. Now, all or none means that when an action potential starts, let's say this is our A zone here, our cell body, they will have the A zone. Now, if it starts here, point A, okay, A here, it must get to B here. It must get to where it's going. Yes, sweetly. And yes, you can talk or mute yourself. Hey, you are not, or why? You always do it and then you mute yourself.
Hello, Mr. Mama.
Yes.
Please, under the threshold,
Yeah.
I saw some sub and supra threshold, but it seems you didn't explain those two words.
Oh, I explained. I said the sub threshold is when it's below the threshold value, and that one will result in graded response or what is that, local response.
Okay, okay, thank you very much.
Yeah. So so I hope that you are fine. And then we're saying that the supra threshold is the one that is high, like is higher than the threshold value. Okay. Now, so I was explaining the all or none. The all or none means that if you start something in action potential, it must complete the task. Like you started to do degree, you must finish. That is what it means. It's not like you get somewhere and say you are stopping. It's not like that. That is not action potential. If you start from A, first year, second year, or you started from access, you have to finish it. That is what it means. So nerve fiber transmit impulse by the all or none principle. So it is conducted along the neuron at constant and maximum strength, independent of any intensity or stimulus. That is what it means. Any intensity or stimulus. Okay. So that is what we are saying. So if it starts at 10, I'm just using 10 as a value. That is what it means. So it usually travel at maximum the same rate to the end of it. Then number 3, see the third property, that the maximum we call it refractive period. Now refractive period, last one I explained that when sodium ion channels are open, they quickly enter into what we call inactivation phase or stage or period. And when they are in inactivating period, when you give a second stimulus, they do not respond to it. We call that one absolute refractive period. So the period when the membrane will not respond to a second stimulus is called refractive period. Okay. Now, there's a period that no matter how hard you stimulate, they will not respond. And that's what that one is called absolute refractive period. But if you allow a small time, then you increase the intensity of the stimulus, then it may respond. And that is referred to as relative refractive period. That is here. So we have relative refractive period in that. Okay. So here we say under the absolute period, the membrane will respond to second stimulus with higher intensity. This period is referred to as the relative refractive period. And secondly, okay, so that is why we are. So I'll take it again. So I'm saying that in refractive period, it is when the membrane, when it's conducting one stimulus, the first one, it will not respond to a second stimulation. And the reason is that the sodium ion channel have entered into inactivation period. If no matter the intensity, the membrane cannot respond, they refer to it as absolute refractive period. But if with time, the membrane can respond a bit, they refer to it as relative refractive period. Yes, Jay, your hand was up.
Yes, please. Can you give practical examples so that we relate to this?
Yeah, so you see that I put example as a WC. That is what I just using that to simulate what I'm talking of. Let's say if you flash your WC, okay, and you want to flash again immediately, it doesn't respond to that. It doesn't respond to the flash. That is what we refer to as absolute. Yes, coming. Absolute refractive period. Okay? But if you allow a bit of time to go through, So if we allow a bit of time for the water to flow in a bit, then you flash again, then it goes. We call it relative refractive period. Okay? Okay. So, hey, Johan, you wanted to say something again?
Yes, please.
Okay.
Please, the WC there is not really relatable. Use heat or maybe cold.
You can't still picture that. You can still picture.
Yes, let's use maybe heat so that there will be a situation where I will touch something very hot. Then maybe it gets to a time that same hot thing, if I touch it, I won't feel it again. That means maybe it has entered the refractive phase. Then maybe there'll be a time I'll
please, can we use
and then I'll feel a pain, and something that is more hotter. Something that is more hotter comes into contact again, and I begin to feel it again. Then maybe that would be the relative refractive.
That's the example you wanted. Okay, that's fine. That's very good. Yes. Somebody was talking to.
I was saying, can we use the electric ion? Let's say when you are ironing and then it gets to a point where the thermostats will reduce the heat and then it will come back again.
No.
Mm.
No, like I think maybe J example is also fine. And sometimes we also use things like if somebody is having labor pain, and then according to the women who receive it, I learned it's even painful than if they give you episiotomy. So they usually wait when the contraction comes. Then they also add the episiotomy. The women who are here, if I receive it, do you feel the pain when you have contraction and episiotomy? They get cut without giving anesthesia. So the cut is a second stimulus. Meanwhile, the pain is already gone with the labor pain, the contraction of the uterus.
Okay.
You may not feel the second stimulus as if the labor pain was not to be there in a way. So you also feel the pain, but not as. So they cut them according to that. So yeah, so that is it. But the WC is just to give you a picture of what we are talking of. That you flush the water just flow there, you flush immediately again, then it doesn't come. That is absolute refractive period. Okay. Then finally, we also have what we call accommodation. Accommodation. Now, accommodation is not the accommodation you sleep in, the house you sleep in, and all that. What it is that if you stimulate a neuron very slowly, the stimulus will pass without an action potential being generated. That is what we are talking about as accommodation. That if you stimulate a neuron very slowly, okay, the threshold would process without the generation of the action potential. That is what we call accommodation. The stimulus had been accommodated. Now, what are the factors that account for accommodation? Yeah, like we were saying that the factor that accounts for refractive period is because the sodium ion channel entered into inactivating phase. What about accommodation? In accommodation, because you stimulate the neurons slowly, the number of sodium ion channels that open to allow sodium ion to enter were not able to stimulate, were not able to accrue or move, let me say that, move the membrane potential to minus 55 at the same time, and therefore action potential will not be generated. I'll take it again. What I'm saying that if at this particular time you're supposed to get about 10 sodium ion channels opening at once, so that you will get to what? Minus 55 millivolts. But because you stimulated a thing slowly, maybe 5 have opened, okay, and enter into inert before another 5, before another 5, before another. So it will not get to inactivating phase. Okay, it will not get to inactivating. It will not get to what? Minus 50. That the firing stage to bring about action potential, and therefore the minimum number of sodium ion channel required is not reached. Like we need 10, for example, but the 10 is not reached at the same time. Therefore, accommodation will occur. That is one factor. Jay, your hand is up again.
Yes, sir. Please. I just want to get it clear with this and then the local response or the graded response.
Okay.
So I know with the graded response, there's a sub threshold. The stimuli is below the threshold that will generate an action potential.
Okay.
So that one, it resolves, there is similar resolve, and then there is no action potential generated. But here, action potential is generated, but still there's something called accommodation. I don't understand.
Okay. No. So if you are linking it very well, and I like it that way. So here, it means that the threshold that you use is up to a normal threshold, but it was slowly done. And because it was slowly done, there is no at one point where the number of sodium ion channel open are up to the required number. Therefore, the membrane potential will not be up to minus 55, which is the fire level that active potential can resolve. So, okay, so I can say that with this one, with accommodation, the threshold is normal. Have you seen that? We said when neuron is stimulated slowly, the threshold process without. So the only difference with the local response would be that the local response is a sub-threshold, and therefore is not able to drive the membrane to the minus 55.
Okay.
And this one, the threshold is up, only that it was slowly done in a way that at once the number of sodium ion channels that are supposed to open are not adequately enough or adequate. Do you get that? So
yes,
second,
please.
before it's slowly done, the potassium ion channel will also start to open. Okay, when with time, while the sodium are opening, some are still opening, potassium are opening, and when you have these opposing forces, one want to send it up to positive, the other one want to send it down to negative, then that means there will be no action potential. There will be accommodation. Okay, so those are the factors relating to that. Now, action potential and velocity. Last I was saying that how fast impulses move is determined by temperature, diameter of the axon, and also whether the neuron is myelinated or not myelinated. Have you seen that? Already the last one like this. If a neuron is myelinated, impulses travel faster. That is what we say. Than the non-myelinated neuron. And the type of conduction in the myelinated neuron is the saltatory, and the non-myelinated is the continuous. But let's take temperature. If the weather or the place is cold, the neuron is exposed to cold weather, impulses travel very slowly. But if it is warm or there's heat, then impulses are faster. And on the introduction, we're saying that we can use cold to even do surgery, to give anesthesia. Like they want to do surgery on the heart. So they do what we call cryosurgery. Cryosurgery, they use the cold ice. When you put it there, impulses transmitted on the body reduces. And we're saying that if you hold ice block in your hand for some time, and you touch it again, you don't feel anything. It's because impulse transmission is cut off or reduced. So temperature affects impulse the speed or velocity. Now, diameter of the axon. If axon is larger, axons transmit impulses faster than narrow axon. Yes, Edward.
Doctor, please, I want to ask about the temperature. Are you talking of temperature in the atmosphere?
Yes, and I gave example of things that we could that could affect our body temperature. Now, even look at, there are some animals which are temperature sensitive. If the weather is cold, like the lizard and those ones, they can't move again. They become dormant. And when they have to lie in the sun. When the sun starts to come, they have to lie in the sun then to increase the heat. They see that they are able to move. It's because of that. So it can be our environmental temperature. So when it is low, you imagine your body, you are very cool, you are feeling cool. Your even metabolism decreases, your neuronal impulses also decreases in a way. But when it is the weather is hot, your whole body is hot, impulsive transmission is high. Is it the same, Gloria? Wait a while, who talk? You can unmute.
No. Sir, please. A theater with the air condition of 16 degrees. Won't it affect anesthesia? What you say about temperature? I'm talking about the temperature.
So, no, but the temperature is what? 16 degrees.
The place is cold, like yes, the place is cold. 16 is cold place.
Yes, but most of the time they cover. But 60 is not all that. I'm just using.
It's cold.
It is very cold. 16.
Yes, very cold. 16 is very cold. Yes.
They always cover the patient in a way.
No, when they're giving anesthesia, where I am now, when they're always the theater is very cold.
Very cold.
Like,
okay.
So just asking if it will not affect the anesthesia.
Yeah, but it rather make anesthesia work, because you don't even want you don't want the impulses to be transmitting or moving faster in a way. In a cold weather or in a cold environment, the impulsive transmission reduces, okay, which is good for anesthesia. But what happens still is that, the body, we call it homeostasis. The body tries to maintain the normal temperature, no matter how the environmental temperature is high or low. Except that when it's too low, and then it's able to listen, but the body is trying to adjust. Okay, so that when your temperature, the environmental temperature is even low, it still try to maintain it between the 36.2 to 37.2, the normal body temperature. So the environment may be very cold, and then it will result in vasoconstriction of the peripheral blood vessels, so that you still maintain that that normal body temperature. And like I said, in the theater, they cover the patient to give more other heat. So using the heat, the cold temperature, like I said, they can use it in some surgery that we call cryosurgery, CRYO surgery. Okay, you can Google, you can read more about that. So they use the codes for that. Okay.
Thank you.
Yeah. So now, so say when warm, they conduct impulses faster, and then look at the last point I was talking of. Localized cooling of a nerve can block impulse transmission. You see that? So if you put ice block on your limb, on your body, for some time, it will block the impulse transmission. You can this one you can try it if you have some ice block in your fridge. When you are at home, you can just try yourself to hold it and see whether you see that it will not be this. Let me see those who are asking questions. Are there questions? Please, at my place, 16 degrees. It's very cold. Hey. Okay. So somebody said 60 degrees for one or 15 HP. What is that? It's not really cold. Yeah. It depends on the house, the horsepower of the. You are not. I thought you were asking questions. So yep. So I have some people hand up here. Gloria, is it the old hand or the current one?
It's old. Sorry.
It's the old one. Okay, the
Yes,
red spot.
Sir, please, concerning when there's cold, the action potential is slow, or the heat transfer is slow.
Yeah.
I want to relate it to when somebody gets maybe a fracture or a contusion, and we apply ice block.
Yes.
It lowers, it slows the pain.
The pain.
Can I relate it to that?
Exactly. You know, as I said it, somebody was saying that what we are doing is nonsense because it's not related. Somebody told me that what we are was it also say what we are doing, it doesn't have a relation. And I was like, look, as a day we apply cold compress, we apply warm compress. Why do we do that? And that is why you are bringing. If somebody have a sprain, we apply cold compress because we want to cool the area and reduce the impulses getting to the brain. Okay, I asked you which part of the brain is interpreting the impulse, and if you see the answers, you just be weeping. Last we said, if you even mention the parietal lobe or post-central gyrus or the somatosensory part, I will be happy. You see, so in order to prevent or reduce the impulses going to the brain, then we apply the cold compress. So that impulses getting there will be fewer. And therefore the brain will not interpret because they depend on how much impulses the brain receives will tell the intensity of the pain. If it receives million impulses, it means the pain is higher than if it is receiving 10,000 impulses per second. It means it will be lower than if the brain is receiving 1 million. So it will create a pain, like according to that. Okay, so severe, then you feel the severity in that. So let's go on. Then I also explained this one, the diameter, if it is larger or okay, whether it's larger, it is faster, and when the diameter is small, then because of resistance, impulse transmission is low. And whether it's myelinated or non-myelinated. So say neurons are divided into three main categories. It can be A, B, or C. So we'll say the rate of conduction of impulses of A cell is greater than that of B cell and B neurons, okay, and greater than that of C neurons. So let's see what A nerves are. The A nerves are all myelinated and have larger diameter. These are short and can conduct impulses of up to 130 meters per second. 130 meters per second. So you see that myelinated neurons, larger diameter, they are short, and these are type A neurons. Type B neurons, okay, so A nerves are concerned primarily for proprioception. When we say proprioception, we're talking about balance. We're talking about your position in space, the position of your head in space. Then pains, temperature sensation, and then autonomic nerves. These are myelinated and they like pain. That's why when something cuts you fast, you get to the brain. Then the brain interprets that. Then the B fibers are middle size. Okay, their refractive periods are longer than the A fiber. You know refractive period, when the neuron will not respond to a second stimulus. Okay, and these will conduct impulses up to 15 meters per second. And they are the preganglionic autonomic neurons. Preganglionic, that is before the ganglion. I believe you should know a ganglion by now. A group of cell bodies in the peripheral nervous system is called a ganglion. So preganglionic means before the ganglion. So they are non-myelinated. These neurons are non-myelinated. The type C1, they have smaller diameter, they are longer, and they can conduct up to 0.5 meters per second. And they are also involved in pain and temperature sensation. Okay, pain, temperature, sensation. So they are involved in that. So those are the different how impulses are transmitted in the neuron. Then let's also see receptors. Now, all these we're saying, we said, when we were to start, we said the nervous system have three components. And then it had a sensory component, it had the integrating interpretation component, and that of the motor component. Now, if you take the sensory component, they have the ability to detect environmental changes. Okay, then they convert this environmental change or stimulus into the action potential. And that component of the sensory component is what we call the receptors. Okay, well, so let me read here. It's saying that the sensory component detects environmental stimuli, yes, which are converted into what? Action potentials, and send that to the central nervous system of the integrating component. The integrating component processes the information, and this is passed into the motor, which generates movement and other functions. So the sensory detection is accompanied by special cells called sensory receptors. Okay, so that when somebody touches you, you feel the touch. If you step on fire, you feel that you are a hot object. You feel that the thing is hot. What is doing that? There are receptors. They are molecules or on the cell, on the body. There are substances that will make you to feel that this thing is cool or this thing is hot. They are receptors. Okay, they are receptors. So let's take in your facility. Yeah, your hand is up. Yeah.
Yes. So because I'm no more a co-host, so I can't.
Actually, we're still co-hosts.
Yes, I had a network challenge, so I wanted to find out. So we learned the other day that the thalamus is the relay center that picks up. Yes. So it is the one that picks up the stimuli. That is where it is dumped, and then it will now pick the stimuli and then say this is for the parietal lobe, this is for the frontal lobe, this is for the occipital lobe, and then it distributes the stimuli.
Yes.
Now, what happens in the case where maybe the thalamus has a problem? There's a problem with the thalamus. How do impulses get to their sites for interpretation?
Very good. Very good. I like the way you are interpreting it. That means there will be lots of sensation because the one that's supposed to relay the sensation, there's injury to that. There is injury, and therefore the information will get to the thalamus, but it cannot go to the parietal lobe for interpretation. Okay, so there will be what? Loss of sensation, anesthesia. The brain will be anesthetic in a way. Okay. All right. So let's continue. I don't know how many minutes more. Let me see. Time.
Please, we have less than 30 minutes.
Yeah, we have less than. I can see that. Yes. So Abigail and Gloria, the result. Do you want me to put them on the page, or I should give it to each course rep? Like I've separated them into nursing, public health nursing, and top up and that of midwifery. So if you want me, I can whether I should put all different in the page, or I should send it to the course rep individually. So when we are done, you let me know which one I should do.
Yes, sir. Please, I think our brain is tired for now. I dream of bread.
Why, Abigail? You already say your brain is tired. Why? Why have you done your brain is tired like that? Don't worry, we are finishing now. So we are saying that receptors. I was trying to use your facility like that. There are some people in your hospital that anything they hear, they run to your manager to inform the manager. Okay, they inform the manager. Oh, somebody gossiping you. This one, those are the. So those people are serving are receptors to the head, the manager, so that anything they hear, they just run to the manager to inform the manager that this person, sometimes they don't even hear properly, but they go and tell the manager this one so that they will get feedback. That is what is happening in the body. When you touch something hot, those receptors detect that stimulus. Or let's say somebody touches you or you, even your eyes, there are receptors there that when you open your eyes, you see something. That thing you've seen is sent to the brain. The receptors in the eye, for instance, are the cone, the rod, and all that. So they detect that, oh, there's something in front of you. Then they send it to the brain. For the occipital lobe, we interpret that information that, oh, this is somebody, this is that, and all that. Okay, so they are receptors. They are receptors that when somebody step on you, then you feel that somebody is stepping on you. Soup. Stay with soup. You can talk.
Okay, sir. So I want to find out whether in our bodies,
yeah,
whether is there a situation where some part of the body will have receptors more than the other side?
Okay. Yes, there are some receptors that are more in particular part of body than the other. And there are some receptors that are localized in one region. For instance, the cone and the rod are only found in the eye. Therefore, the eye are special organs. So when you have organs which are having some receptors that cannot be found in all the parts of the body, then we call them special organs. For example, the eye, the ear, we have the receptors for hearing, which is not found. You don't have receptor in your palm for hearing in your feet. It's not there. You don't have eyes or the cone and rod in your thigh. So that means they are only located in the eye. That's why they are called special organs. The ears are special organs. Taste bud are only found on the tongue and maybe the lips, or let's say the mouth. So they are special organs. Okay. But if we have receptors that are located every part of the body, then we call them general sensory or sensory receptors. They are general. They can be found in every part. For example, temperature receptors, they are called thermoreceptors. You can, any part of your body that you touch, it will be, or the heat on it, you'll feel the heat. Okay. But aside that, let's say touch, there are some parts of the body that maybe touch receptors are more. Is that not what you want to hear? Touch receptors are more. Let's say if you take the nipple, when they tie the nipple, the touch receptors they are more. The clitoris, the glans penis, and all that touch receptors are more. So that when you tie the person feels. So the receptor will now detect the stimuli and convert it to the acting potential or the nerve impulse. And the process that enables the sensory receptor to respond visually to the stimulus is called sensory conduction or transduction in a way. Sensory transduction. Okay, so these are some ways in which these things are, sensory receptors are classified. They can be classified based on the origin, the location, or the type of stimulus they detect, or how complex or simpler they are. So if you take the location like this, some are located outside called enteroceptors. Some are inside called interoceptors or visceroceptors. And some are at detect the position of the body. So we call them proprioceptors. So if you read that, you will get that. Okay, so this is the same thing. Then the type of stimulus includes mechanoceptors, like those for touch and all that. Then we have, okay, so those for touch, pressure, vibration, proprioception, hearing, and equilibrium and blood pressure. These receptors are mechanoceptors, like mechanical deformation of these receptors will enable them to relay an action potential to the sensory component of the nervous system. Then thermoreceptors, they detect changes in temperature. Photoreceptors detect light, sensation. Chemoreceptors detect taste in the mouth, the smell, okay, and then chemical in the body. Then osmoreceptors detect osmo concentration. And nociceptors detect pain. Any place there is pain, they detect the pain. And now convert the pain into what? Action potential. So if the pain is actually traceable, then it results in depolarization and repolarization. And that will travel either through saltatory or continuous process or conduction to the brain for interpretation. Okay, so it's the same thing here that we have. And like I already explained that it may be general or special. And general receptors are receptors that are located in all parts of the body. And these examples are the touch, like we mentioned, pressure, vibration, heat, or cold, and pain. Okay, these are simple receptors, and their neural pathway are also simple. These are associated with that. Then the complex ones are those that are like complex receptors and neural pathway are associated with the special senses. Okay, special senses. And each of the special senses has just one or two receptors that are found in specific areas of the body. That is what I'm saying. So they underline that. They are found in specific areas of the body. Okay. These are the tastes we mentioned as smell, sight, hearing. Okay, hearing. And that is the end of it. Thank you. Any question? Yes. Eric, your hand is up. You can unmute yourself.
Okay, sir. Please, what is osmotic concentration and where can they be found in the body?
And like in the body, where we have chemicals like sodium ion concentration, calcium ion concentration in the blood. Okay, potassium ion concentration. So the level of ion concentration in the blood, okay, will also be detected by the hormone receptors in that. Okay. Yes, soup.
Sure. I kept it in the chat box, but you didn't see. I want to know like much about this thing, myelination, that particular word. If you can explain it well.
So myelination. So we're saying that when the axon, we have, I'm drawing it. You have this is cell body, then you have the axon like this. Okay. So I'm trying to draw it here. Now the axon will now be covered by oligodendrocytes or oligodendrocyte or swan cell, depending on whether it is okay like this. So I see, or you can see now. 81. 81 or 80. 81. Yes, one. Why any problem? So I'm coming. And so this is why we are talking of. Sorry, I want to attend to something again. Okay, so this is what we are having. Now, so when we say myelination, it is when the myelin sheath cover the axon like this. So this is the axon. Then we have the myelin sheath covering it, leaving some gap between. These gaps are called the notobrachiae. So these are the notobrachiae. Okay, so that when there is impulse jumps from here to here to that place and to this, and continue like that, making impulse transmission faster. We call it saltatory conduction. Okay, so this covering of the axon is what we refer to as myelination. So the axon can be covered in the brain by oligodendrocytes, but in the peripheral nervous system by the Schwann cells. And we call that myelination of the axon. Sedu, Suk, that is what it means. Okay. All right. So okay, there are some questions on the chat. The result. Yes, I can see. Oh, okay. You say you could see. Oh, the thing has gone. Maybe because of the man. What is that? Okay. I don't think there are any questions. I can't see. Okay. Please add. Are we done with neurophysiology? Yes. So for now we are. Yes. So we can stop with this one. We're supposed to also look at the parasympathetic and sympathetic nervous system, but I think it's fine. It's fine with this one. Okay. So we'll do the reproductive physiology, female reproductive physiology on Friday. Okay. Female reproductive physiology on Friday. But we'll also do the anatomy of female reproductive system. Okay. So, I think that is it. Yes. So now the class rep. Should I put it on the class rep page, all of them? Then you now forward to your respective classes. I think that's what I'll do.
No.
Yes.
Please, if you can kindly segregate it into the respective classes.
Yeah, it has been segregated. I've already done that. But I'm asking whether I should just give it to, if the class rep directly, let's say me with free class rep, then probably health. And then
I think that would be fine, so that
would be fine.
I cannot go for that of public health and look at the result. So send it individually.
Okay. So that what will happen is that public health, and I send me hi to my WhatsApp page. Okay. So that when I'll just drop it for the public health, nursing, top up, and which one? Midwifery. Yes, midwifery. So do that now. I'll just drop your listing for you. Okay. Thank you very much, and have a sound sleep. Go and read all that we've done. We are going to write IA in neurophysiology on Friday.
Sir.
Yes.
Sir. Hello. Please, can you hear me? So, about the lecture on Friday, some of us will be coming on Friday. So, lectures on Friday might not be possible.
Okay.
Not even talk of an IA. Yes.
Okay, so that means we should do the IA tomorrow.
No, maybe when
Is there when you can? Okay.
Yes.
So I'll think about it.
Sure. Thank you for understanding.
No, I'm not understanding. Friday, Wednesday, and Thursday. They are all days. So
we will be preparing. We'll say our brains will be hot. So I think when we come, it will be fine. Because we'll be preparing throughout the week is for preparation. So we leave on Friday or Saturday on Sunday. So I think when we come, it will be fine.
Where are you coming from? Which part of Ghana?
Me, I'm coming from Cape Coast, so all the way, far away.
Hey, Cape Coast is not far. What of those coming from Volga and Hamele, Nandom, and all that? What did you say? Cape Coast here is not far. Okay, so I wish you all the best.
All right, sir.
But we'll meet for anatomy. When are we meeting for anatomy?
Unless I check the timetable, but I think we can meet before Thursday or so. I think we have a lecture on Wednesday. I think Tuesday, Wednesday, Friday, or so. I don't really remember, but unless I check on the timetable.
Check it then update me. All right.
Okay, please.
Bye-bye.
All right.
Somebody said for us not to forget of our Gary, let them do it when put the Gary in the back already. Now you forget it. Hey, it's serious. But now you remember the Gary, so why don't you put the Gary already before you write the exam? When you write the exam and then the brain is hot, then you just pick your back off and up to go. That is all. So you don't need to think about whether to pick Gary or not. The Gary is already in the back, okay? All right. I wish everybody well.
Sir, please, the recording, please send it to the Telegram so that we can share it.
Okay.
Okay, thank you.
Thank you, sir. Bye-bye.
Bye-bye. You send me hi for your result.
Okay.